Hello, physical systems. I'm looking at the answers you guys gave me to yesterday's question, and I'll just go over the question again. So the question is, your car is on a driveway, not moving, and the force of gravity is pulling it down. So let me just stop there for a second. So anything that has mass and is on the Earth is bound to the Earth's gravitational force. Hopefully that's something you guys read about. Remember, gravity is just the force that any two masses will attract each other. So a car has mass and the Earth has mass. Therefore, the car is exerting gravitational force on the Earth. But the much stronger force is the Earth's gravitational force on the car. So the car is pulling the Earth is pulling the car down. Wish I had my tour car with me. Anyway, so why is the car not moving toward the center of the Earth is the question. So one of the things we said is that the force is a push or pull in a certain direction. And today you're going to learn that forces cause accelerations. So why is the car not accelerating? Why is the car standing still? Let me just kind of go over the answers you guys gave me. This is something we're going to talk a lot about next week when we start diagramming forces. Somebody says it has mass because somebody says because the ground is stopping it. The gravity has opposite reaction. Gravity is a non-contact force. There's no force to make it move because the pavement is holding it up. Gravity exerts a downward force on the car, which is true, but that doesn't answer the question. Gravity is pulling it down. Again, that's true. It doesn't answer the question, though. Somebody said friction keeps it still. Somebody says objects at rest tend to stay at rest, which is true. This car is at rest, so it wants to stay at rest. And somebody had the same thing. So, yeah, lots of those are true in their own way, but still is not answering the question. We could say friction is acting on the car. Maybe friction is preventing it from going down the hill. But let's just kind of think about a flat driveway for a second. Let's see if the car is if we have a car in a flat driveway. Let me get some props here. This is kind of last minute here, if you can't tell. Hang on. All right, so let's pretend this is my car, okay? Or my object. And here's my driveway, my nice backyard physics book, okay? So here's my driveway. Here's my car. So why is if gravity is pulling this car down, why is it not going through the driveway? A lot of you guys kind of caught it because somebody said the ground is stopping it, and somebody said the pavement is holding up. So there is a downward force of gravity, but in order for this thing not to accelerate, there has to be another force that balances the downward force of gravity. And this is called Newton's third law. Newton's third law says that that forces always work in pairs, which means that in this case, gravity is pulling the car down toward the pavement, but that means the pavement has to be pushing up on the car. Now, if the car is falling, it's a little bit of a different story. We'll talk about free-falling objects later. But for this example, the car is being pulled down by gravity. The reason that the car is not moving through the pavement is because the pavement is pushing back up. That's called the pavement's reaction force or normal force. So it's not intuitive. It's not because we don't really think of something that doesn't have the ability to move, like a piece of pavement, as being able to push back up. So when we say that the pavement is holding the car up, we're really saying the pavement is pushing the car up. It's preventing gravity from pulling the car through the pavement. Now, let's say that if we increase the car's mass, we just like put something on top of the car. If I keep on putting more and more mass on top of this car, eventually the pavement's going to break. So there is a limit to how much the pavement can push. You kind of consider that like the pavement's strength. So there's a maximum force that you can put on the pavement before the pavement can no longer be pushed up on the car or whatever you have on top of it. But for this example, our car is light enough that the pavement can push back up and counteract that force of gravity. Again, that's Newton's third law. So if you still need some help, you might go back and read about Newton's third law again from earlier this week. Please let me know if you have any questions. And I'll talk to you guys later. Bye.